Hi, this is Miss Smith, and in today's short video lesson, we are going to cover percent of error. Now, percent of error is very similar to percent of change, but there's one slight minor, it's not really minor because if you miss it, you're going to get it wrong. So it's not a minor difference, it's a major difference. So make sure you're paying attention because although the formulas seem like they're the same, it's not. So, word to the wise, pay attention. Here we go. By the end of this video lesson, you should be able to do the following. You should be able to explain and calculate your percent of error. And number two, you should be able to round to the nearest percent. Let's go ahead and get started. All right, in this problem, I'm going to shout out to Raymer. Raymer is one of my amazing, awesome students. He is also in the band, so you might know him from class, you might know him from the band. And in our example, Raymer is practicing his trombone solo for the upcoming band concert. He estimates that it will take him about 60 minutes to learn how to play his part perfectly. Now, the actual time it took was 42 minutes. So once again, he thought that it was going to take him 60 minutes to learn his solo. It actually took him 42 minutes. So this problem is asking us to find the percent of error. And it's also asking us to round the percent of error to the nearest percent. All right, I'm going to go ahead and go to the next slide because I have a feeling you're looking at these pictures and I need you to focus on the problem. So there we go. All right, let's go back to the question. The question is asking us to find the percent of error. So we're going to start there. And I'm going to set this up as a proportion. Now remember, your percent is a number over 100. And in our example, our percent is going to represent our percent of error. Okay. And we're going to set this equal to another fraction. If the numerator here represented your percent of error, the numerator here is going to represent your amount of error. All right, so let's think about how to calculate the amount of error. If Raymer thought it was going to take 60 minutes, but it actually took 42, by how many minutes was he wrong? All right, well, hopefully you realize that in order to find the amount of error, you're going to subtract. This is exactly what we did yesterday when we talked about percent of change. So you're going to subtract to find the amount of error. Now on the denominator, this is where you have to be careful. On the denominator, we're going to write the actual time that it took. All right. So on the denominator here, we're going to put the actual time that it took Raymer to perfectly play his trombone solo. All right, so we have the formula. Let's go ahead and plug in the information. All right, we do not know the percent of error, so I'll put x over 100. All right, now we're going to calculate the amount of error. Well, if you thought it was 60 and it was actually 42, we're going to subtract that. On the denominator, it's the actual time. So it actually took him 42 minutes. All right, let's simplify. X over 100 equals 60 minus 42 is 18. And it's going to be 18 over 42. So let's make sure that we understand this. The amount of error that he had was 18 minutes out of 42. So if he was off by 18 minutes out of 42, what is this as a percent? All right, let's go ahead and solve by cross multiplying. So here we go. Make sure this is set right. All right, let's go ahead and cross multiply. 42 times x and 100 times 18. So x times 42 is 42x and 100 times 18 is 1800. All right, solve for x by dividing both sides by 42. Cancel out the 42 and we're going to be left with x is equal to, if you do this in your calculator or on the side, 42.857, and I'll stop there. All right, now this is our answer as a percent, because remember, x was your percent. So this is our percent of error. But we want to round this percent to the nearest, percent. So what does that mean? That means we're going to round it to the nearest whole number. So we want to ask ourselves, is this closer to 42% or 43%? In order to determine whether or not this is closer to 42 or 43%, we're going to look at the tens place. And if this digit, remember, is 5 or more, we're going to round the 2 up to the next number. So in this case, 8 is 5 or more. So 42.857 is actually closer to 43%. Okay, 42.8 is closer to 43%. So our percent of error is 43%. All right, I'm going to go ahead and write this answer as a complete sentence. All right, so I will say that Raymer was off in his estimate by 18 minutes, which is 43% of the actual time. The actual time was 42 minutes. So it is 43% off of the actual time of 42 minutes. All right, there is our solution. Let's go ahead and summarize this up. In summary, percent of error is a percent that represents how far your estimate is from your actual value. And the percent of error formula, make sure you commit this to memory. The percent of error formula is right there. All right, before I close out, I just want to share a picture of myself as a high school senior. This is me. In 2003, graduated from high school. This right here is my big brother, Rod. We're actually 11 months apart. And the reason why I throw this photo up is because I too, like Raymer, and many of you guys, like Ivan and Shayna, Shane, Sarah. I know I'm missing some people, but many of you guys are also in the band. So when I hear about things that you guys are doing that kind of reminds me of great days in high school, I really, really get excited about that. So if you're in the band, keep up the great work, and go Pumas. All right, that's the end of our lesson. Hey, I just wanted to come back and edit this to say Sean, not Shane. Who is Shane? I don't know. I'm tired. Good night. Peace out.